Comes on everyone. So last class we have done center of mass of particles. Like I said, today we'll be doing for continuous bodies. Hope everyone has revised the calculus notes. Today's class is quite important, so do focus because whatever I'm going to teach you today, choosing elements and stuff, which we have done in calculus a bit, but we're going to use this literally every other chapter. So let's go ahead. Center of mass of continuous bodies. The first step we will take is a uniform rod. We know uniform rod result is at the center, but listen carefully how to take an element and how to do it. So I'll show you a process. So consider we have a rod x is equal to 0, x is equal to L. So we define, these are the symbols, lambda for linear density. This is mass per unit length. We define this for rods. Example, if someone tells you lambda is 3 kg per meter, the meaning is the mass of 1 meter rod is 3 kg. So we use the symbol lambda for arcs or rods. Sigma is surface density. This is mass per unit area. This we use for sheets. Rho is your volume density. That's what you studied in school. It's mass by volume. So for this rod, we have linear density. This is lambda. Now let's see how to choose elements and solve this. One second. Someone is missing. Why are so many people missing? Now let's see how to do this thing. Consider at a distance x. Consider a small piece dx. Now, why are we doing this? Because if you remember the Center-Musker formula, integral x dm, now the mass is not at a single place. Mass is here, mass is here, mass is here, mass is at every point. So I can't use this and solve directly. So I need to take a small piece. So here the elements that we choose are small rods. So this is what we do. So dx is a small rod that can be treated as a point mass. That is the whole point of integration. You're taking such a small piece that you can think it's like a point mass. So what is dm? Dm is linear density lambda into length of the rod dx. Done. There you got everything. So that means for this small rod here, the coordinates are x comma 0. You're using the formula x center of mass integral x dm by integral dm. So x dm is lambda dx. Limits will go from 0 to L because all these pieces are from 0 to L by integral lambda dx from 0 to L. This is lambda integral x dx from 0 to L by lambda integral dx 0 to L. Lambda lambda will cancel. This will be x square by 2. Limits 0 to L by x, limits from 0 to L. That is L square by 2 by L, L by 2. I know it looks obvious. We know it is at the center. But this is how you follow the process. Again, listen what I did. Listen, everyone. At a distance x, take a thin piece dx. The dx is so small, you can assume it is like a particle. So for this particle, the coordinate is x comma 0. So for this particle, the mass dm is lambda, that is mass per unit length, linear density, into the length of that small rod dx. So I got dm, I know the coordinate. Then for continuous bodies, we know the formula is this. Integral dmx by integral dm. I substituted there and I integrated. Please have a look at the process. Clear, everyone? Using this, now you guys try to solve. Let's say I have a rod here, x is equal to 0, x is equal to L, and let's say lambda is equal to lambda naught x square. Find the center of mass. Lambda naught is constant. X is your x coordinate. You should know your process. Now, you look at this is the process. The only difference is this lambda ka place mein, you will get lambda naught x. That is the only difference. Everything else is same. There, have a look at the question. I will show you the previous solution also. You can use that as a reference and solve. So here the density is not constant. What do you mean by this? Look at this. When x is 0, there is no mass. X is equal to 1. You have some mass. X is increasing more mass. More, more, more. You're getting the rod is becoming more heavier and heavier as you go to the right side. So this rod is becoming heavier to the right. It's not a uniform rod. It's a non-uniform rod. There you can have a look at this working and try it. Yeah. Try it. I got a minute, everyone. Just a matter of putting there and integrating. Right, Ansh. Right, Vihan. Try others. Let's see. Same story at a distance x, take a small piece. So why are we taking it at distance x? So the idea is this. The idea is if I put x is equal to 0, then this piece will be here. If I put x is equal to L by 4, this piece will be here. So by changing the value of this x, I'm able to choose different points on the rod. Are you getting the meaning? So when I say at a distance x choose dx, that is the meaning of it. Means I can choose different points on the rod at different positions. So this coordinate is x comma 0. So dm will be lambda into dx. This is lambda naught x square dx. So there I got my dm ka value. Y coordinate is anyway 0. So integral x dm by integral dm. Like I'm saying, the integration is actually the easiest one. It is just x power n ka integration. The headache is choosing elements and solving. This would be lambda naught x cube dx. Check. Easy. Any doubts on this? Next one. Turn in the page. Clear na Adi? Ahana, got this? Now let's do something better. Let's say I took two different rods. X is equal to 0. This is x is equal to L2. Let's say this is lambda 2, which is lambda naught x is x. The left side of the rod, x is equal to minus L2. Lambda 1 is lambda naught x square. So you took two non-uniform rods. The right side ka rod is lambda naught x, left side ka rod is lambda naught x square. And then you joined both these rods. And it is observed. So find the relation between L1 and L2. If the center of mass is at the origin. Meaning, see, just to give an idea, this green one will have center of mass somewhere here. The red one will have a center of mass somewhere here. So I'm saying this center of mass and this center of mass, ka center of mass is at the origin. Means for the full rod, the center of mass should be at x is equal to 0. This will not happen for any length. It will happen for a particular value of L1 and L2. So what is the relation between L1 and L2? So we have taken two non-uniform rods and joined them at the origin. Find the relation between L1 and L2 if the center of mass of the whole system is at x is equal to 0. Question is clear, everyone? Yeah. Today there'll be no break. Huh? We will just wrap it up like by 7:30 or something. So next week onwards, we will have till 8. How do we do this? Think. I'll give you a minute and then I'll tell you a bit of an idea. Yeah, that's not the answer. Nope, nope, Devansh. I'll tell you something. See, listen. Do you agree this green one will have centroma somewhere here? Agreed? Can you find the mass of this thing then? You can find the mass of the green rod, you can find the centromass of the green rod. Similarly, you can find the mass of this red rod, you can find the centromass of this red rod. Do you agree? Now, doesn't this question become like there are 2 points, and now I'm telling these 2 points the centromass is origin? Isn't that the question? You know how to find the mass of each rod, you know how to find the centromass of each rod. So make this problem into 2 particle problem. So forget about the rods, make them into particles, and then find the centromass of these 2 particles. नहीं विहान, नहीं जैनिल. ऐसा नहीं आएगा ना आंसर. It's not a linear functions. You guys are not calculating mass. You're just taking centromasses and trying to equate them. Do you think the mass of both the rods will be same? So it should be like M1 L1 plus M2 L2 must be 0, na? I hope what is the basis of the question. Now try. I'll give you another minute or two. You have to find the mass of each rod. You have to find the centromass of each rod. So then the problem has become like 2 particles. One is on the right and one is on the left. And now you're saying these 2 particles with different masses, the centromass is at the origin. हाँ Daksha, you have to find the terms of L1 and L2 का relation आएगा कुछ.
Yes, in terms of x.
In terms of
X.
X. What is X? What is X? X तो दिया नहीं क्वेश्चन में. X is something which you assume, right? L2 by L1 is cube root of 3 by 4. नहीं रे परोजा, that's not right. Vihan L1 path 4 by L2 cube. You got the powers right, then you messed up the numbers. There are numbers also there.
So I'm seeing that like the power should be added to my original answer.
Then type the proper answer ना. ये क्या है? You send bits and pieces and I should assemble everything. I क्या है क्या ये? So first I sent L1, now I'm sending L2, I'm sending cube. You please add all this and make your own answer. Don't send an IKEA furniture. तो अच्छे से answer भेज. 3L1 power 4, 4L2 power 3. हाँ Jainil, that looks right. You went behind. ना? You're IKEA fan, I understood. हाँ. See. So let's just take each one separately, okay? First, let's take the red guy. X is equal to 0. I will just take it as plus. We can solve it later on. Set a distance x. You take a small piece dx. So this was your lambda 1. Was lambda naught x square. So dm will be lambda into dx, which is lambda naught x square dx. Same story. So first thing, mass of this rod, let's call it m1, which is integral dm, which is lambda naught integral x square dx from 0 to L1. This is lambda naught L1 cube by 3. That is the mass of this left side rod. Center of mass will be integral xdm by integral dm. This would be integral xdm will be lambda naught x square dx 0 to L1 by integral lambda naught x square 0 to L1. Lambda naught will cancel. That would be L1 power 4 by L1 cube by 3. This we did just now, previous problem, 3L1 by 4. Means that left rod ka mass is this much and the center mass is 3L1 by 4. Similarly, if you take this green rod, the right side ka piece, x is equal to 0, x is equal to L2, and lambda 2 is equal to lambda naught x. Same story, at a distance x, take a small piece. dm will be lambda dx, which is lambda naught x dx. So mass of this rod will be integral dm, which is lambda naught x dx, 0 to L2. This is lambda naught L2 square by 2. And for this rod, the center of mass will be integral x dm by integral dm. If you see, the integration is actually easy. It is only x power n. The headache is elements and stuff. That lambda naught will cancel. You end up with L2 square by 2, L2 cube, L2 cube by 3 by L2 square by 2, 2L2 by 3. Check. This is the mass of each rod and this is the center mass of each rod. Any doubts on this? This is same as the previous question. Once you got this, now you're saying that this rod x is equal to 0, x is equal to L1, x is equal to minus L2. So this guy is as good as having a particle M1 whose center of mass is minus 3 L1 by 4 comma 0. This entire right side rod is like M2 and this is like 2 L2 by 3 comma 0. Isn't this what we wrote in that? If a system is divided into n parts, then the center of mass of this each part is the center of mass of the whole system. So if I can treat each rod as one particle and I can find the center of mass of those two particles, that should be the center of mass of the whole system. Now you're telling the center of mass of these two particles, so x center of mass must be m1 minus 3l1 by 4 plus m2 2l2 by 3 by m1 plus m2. This is given, it's at the origin. Now what is m1? M1 is this guy, lambda naught L1 cube by 3. So lambda naught L1 cube by 3 minus 3L1 by 4 plus lambda naught L2 square by 2, 2L2 by 3 is equal to 0. Lambda naught goes off. L1 power 4 by 4 is equal to L2 cube by 3. That's your answer. If this condition is satisfied, the center of mass will be at the origin. Is this making sense, everyone? This is how they'll frame an advanced question. Even at an advanced level, this is an easy one. So it's based on this. Any doubts on the steps, please ask me. There, this was the main concept I was saying about. If I give you some weird shape, it doesn't matter. Split that into pieces, find the center mass of each piece, and then finish it off. Clear? Let's see one more. Any doubts on this? Anyone not convinced with this? Please ask. Can I go ahead? Daksha, got it? Nikhil, Pratik, Sharman. Perfect. Next one. So we have a rod here. It's a uniform rod bent into a it is bent as shown. This angle is theta. This angle is theta. This is 2L. This is L. You can take this as x-axis and this point is origin. Find the center of mass. This will be a proper main level question. Again, just to give you an idea, can I say like this? I can find the center mass of this rod somewhere here. I can find the center mass of this rod somewhere here. I'm asking you to find the center mass of these 2 points, isn't it? Isn't that the story every time? Because for a uniform rod, it will be at the center. So treat that as 2 pieces. You'll get 2 particles, finish it up. Answers everyone should try. Everyone should give it a try. You can take whatever components you want. Let's see the final answer though. Okay, we have one answer, but let's see. Anyone else got the same thing? Hmm. Okay, we have two answers, same Bihan and Ansh. Let's see. Try, give another 30 seconds. Let's see. So here, one thing you have to be careful. The most common mistake what people do that I saw. Now for this center will be somewhere here. This length will be L, the midpoint. So from here, if you drop a perpendicular, so these coordinates will be L cos theta, comma L sin theta. Similarly, if I take this guy, this midpoint will be L by 2. So when you drop a perpendicular, this coordinates will be L by 2 cos theta minus L by 2 sin theta, minus because it is a negative y coordinate. The mistake is this. If this is mass m, this has to be 2m. Hope you have taken the mass is different because the length of the rod is more. Getting it? So 2L length will have double the mass. That is one thing. Generally, people go for that part. They take the masses same. Done. Once this is over, x center of mass will be 2m L cos theta plus m L by 2 cos theta m1 x1 plus m2 x2 by m1 plus m2. This will be 2 plus half 3 by 2. 5 by 2. So 5L cos theta by 6. This would be 2ml sin theta. L by 2 sin theta. Check your answers. That is 2 minus half is 3 by 2. 3 by 2 by 3, 3 will cancel. There, once you got the coordinates, it's just a matter of putting there and solving. Any doubts on this? Clear, everyone? Then let's see one more. Going ahead, any doubts? Surya, clear? Aryaman, Arush, Adi, Ansh, clear na? You also got it, Ansh, right? Next one. Let's say we have a beautiful caterpillar. So we can treat this as a uniform rope. It's a uniform caterpillar. Length of the caterpillar is L. The caterpillar is going with a constant speed U. So T0, this is the scenario. The caterpillar is about to climb the wall. After time T, this is how the caterpillar is. Okay. So at T0, caterpillar starts climbing the wall with a constant speed. Find the center of mass. Find the velocity of center of mass. Find the position of center of mass. Find velocity and acceleration of center of mass. So find position, velocity, acceleration of center of mass at time T, where T is less than L by U. Why T less than L by U? At L by U, the thing would have completely climbed the wall, right? So I want a situation where some part is on the floor and some part is on the wall. We are doing only till then. If once it completely climbs the wall, we don't want to do. Let's get this. Hope the question is clear. You can appreciate the caterpillar also for some time, but let's get it. What do you think, Vihan? You tell me your feeling. Because exam I won't be there to answer this question, what you're asking.
Sir, instantaneous.
Okay. So what made you think it must be average? If
Sir,
it is
that
average,
is-
won't I ask you average?
Yes.
Keep that in mind, because if they don't mention anything, it is always instantaneous. And why did I say at time T? I didn't say up to time T, like, find the average for it, that would be different interval time T. Get this. Nothing is mentioned, always instantaneous. Two people are missing. How do we approach this? It's a pretty good one, right? It looks silly, but you would ask me it would be a good advanced question. At an advanced, it'd be like it's a easy to moderate level. They can even ask you find the normal reaction on the wall and the floor. Try. First, find the position. If you get the position, you'll get everything. So just to give an idea, you can treat this like one rod and treat this like one rod, isn't it? So each rod will have center of mass. So I'm asking center of mass of these 2 points, isn't it? Isn't that the question end of the day? So after time T, it's like two rods vertically placed. masses, find their center of masses, and find those 2 points का center of mass. L minus ut by 2 so you messed up something. You took the coordinates, but you took the masses different. Mass also change hoga na? Isn't mass changing with time? Look at this. So I can treat this caterpillar like 2 rods. So after time t, this length will be how much? This will be ut. Then this length will be how much? This will be L minus ut. Agreed? So in time t, the caterpillar will climb the wall ut. So for this thing, the center of mass will be here, whose coordinates are 0, ut by 2. For this thing, the center of mass will be here, which is L minus ut by 2, 0. This piece ka mass will be m1, this piece ka mass will be m2. So there are 2 pieces, one piece on the wall and one piece on the floor. What is m1? M1 is total mass by total length into length of this piece, L minus u2. What is m2? Total mass by total length into ut. Agreed, everyone? So mass of each piece is also changing. Now I'm asking you to find the center of mass of these 2 points. So x center of mass will be, actually I can directly find the position vector. R center of mass will be m1 r1 bar, which is L minus ut by 2 I cap. 0 is anyway j cap there. M2 into ut by 2 j cap by total mass m1 plus m2. So m1 is m by L minus ut ka whole square by 2 I cap. This is m by L ut whole square by 2 j cap by total mass is again m. M will cancel everywhere. You end up with L minus ut whole square by 2L I cap plus u square t square by 2L j cap. This is your position vector of center of mass. Meaning this is your x coordinate and this is your y coordinate. Makes sense, everyone. I cap, j cap, don't forget. Now you want velocity. Velocity of center of mass is simply differentiate dr by dt. Now if you differentiate this, I'll end up with 2 into L minus ut minus u chain rule, everyone, by 2L. It is something to the power of 2. So 2 into something and differentiate whatever is inside. This guy will be u square t by L j cap. U will cancel. This is minus u into L minus ut by L I cap plus u square t by L j cap. You want acceleration? Differentiate again. This would be minus of minus, that will become plus u square by L I cap plus u square by L j cap. Acceleration is constant for this caterpillar. Have a look at the steps. So the main idea is each piece ka mass changes, each piece ka coordinates change. So you get a square there. Once you got the coordinates, you just have to differentiate 2 times to get acceleration. Check. Anyone not convinced with anything particular steps here? Any confusion? Please ask. Clear? Next one. Any doubts on this? Keep it in I cap, j caps because it's a acceleration, velocity, all these are vectors. It's a pretty good question. I should try this again. Now just imagine it's not going with the constant speed, it is accelerating. It gets more messed up. Next one. So that is about the rods. The next shape we're talking is arc. So if you take an arc like this, it's a uniform arc. Radius r. This angle is theta. Linear density lambda. Now you can see here by symmetry, if you drop a bisector, isn't the left and right equal? It's a line of symmetry. So that means I'm sure the center of mass will be somewhere on this line. So my x coordinate is 0, but y coordinate I don't know. So in this, the elements are small arcs. So I'll show you one how to do this. Listen carefully. So whenever you get this shape, now this is not the first time you'll see it, sir. You will see this again in rotation, electrostatics, magnetism, gravitation. You will see this in multiple places. But in any chapter, this is how you always start. So we take the bisector as a reference. So from here, at an angle alpha, we take a very thin slice, d alpha. So this d alpha is so small, I can treat this like a particle. So rd alpha is like a small piece, can be treated like a particle. So this is a small arc, which can be treated like particles. That was the whole idea. You want to create small pieces. Now for this small particle here, if you take the coordinates, that would be this radius is r. So r sine alpha, r cos alpha. So these are the coordinates of that small piece. Perfect. So mass of this small piece is lambda into length. Length is rd alpha. This is the mass of that small piece. Now this angle alpha at the center, alpha is 0. Means when you take alpha 0, you're talking about this particle. If you go to the right side, this point alpha is theta by 2. And this point alpha is minus theta by 2. Why plus and minus? The total angle is theta. If you go to the right side, it is half angle. If you go to the left side, it is a minus half angle. Are you getting how I'm getting the limits? So here alpha varies from plus theta 2 to minus theta by 2. Because you are measuring the angles from the center. There, you got everything. So x center of mass, the formula is integral x of the arc. So this is the formula there. You're basically treating each arc as a particle, dm of the arc. So the x coordinate of the arc is r sine alpha. Now I know x coordinate must be 0 because of symmetry, but let's prove it. Lambda r d alpha limits go from minus theta by 2 to theta by 2 by lambda r d alpha minus theta by 2 to theta by 2. That's what I'm saying. Getting till here is the headache. After this, it is easy to solve. This is lambda r square integral sine alpha. So it is just a sine alpha ka integration. So you will get 1r. Sine alpha ka integration is minus cos alpha. Limits minus theta by 2 to theta by 2. This would be alpha minus theta by 2 to theta by 2. So this is minus r. We get cos theta by 2. Cos minus theta is cos theta by 2. They will cancel. You get 0. As expected, x coordinate is 0. No, it should be on the bisector, isn't it? If this was the origin, I know the centromas will be somewhere here. So x coordinate is 0 as expected. Now using the same logic, can you guys find the y coordinate? Now you try. You get the y coordinate. So the only thing that will change is x ka place mein y aayega. So r cos alpha must be here. Now you try the y coordinate. Get it? Everyone should try. Anyone didn't get this process, please ask me. We know x coordinate is 0, but still I proved it and showed it to you. This is how it is done. Now you try for y coordinate. I'll give you a minute and a half. No matter which chapter you take, whenever you see an arc for an integration, this is how it starts. For example, there, see, this is a question in electrostatics. There is a charged ring, find field at the center. You see how the element is taken? It starts like this. No matter which chapter, the element starts like this. Get it? I got you the x coordinate, you get me the y coordinate. So you just have to replace y, x ka place mein y everywhere and finish it off. Y coordinate is r cos alpha. Now it won't be 0. R into 1 minus cos theta. Nee re Ansh. God, lambda कहाँ से आएगा रे God? Dimensions are not matching. There is a lambda in the denominator, so that will get cancelled out. You are right, Puroja. You got it. Yeah, one answer. Okay, Ansh, wait. I think you also got it. You didn't simplify it further, I guess. No, no, not right, not right. You're wrong. In your case, you'll get a square unnecessarily. Vihan, you got an R square. Dimensions. Chord. You're finding coordinate. फिर भी, the remaining part is wrong anyways. Check. See where you guys went wrong. So why center of mass? There's no physics there. Pure brute force max this is. Y arc, dm, by the moment you found the dm, you're done actually, and the coordinates. The y coordinate is r cos alpha. This is dm is lambda r d alpha minus theta by 2 to theta by 2. by integral lambda r d alpha minus theta by 2 to theta by 2. This is lambda r integral cos alpha d alpha minus theta by 2 theta by 2. Cos alpha the integral is sin alpha. So this is r. Sin alpha limits will go from minus theta by 2 to theta by 2 by this is theta. Sin theta, sin minus theta, that would be sin theta. So sin theta by 2 minus of sin minus theta by 2. Cos minus theta is plus cos theta, but sin is not like that. We get 2r sin theta by 2 by theta. Check, that's your answer. So if someone gives you an arc, theta, the center of mass will be somewhere here. It will be on the bisector at a height of 2r sin theta by 2 overall by theta. Suppose if theta is equal to pi, it becomes a semicircle. For a semicircle, it will be again on the bisector. It is 0, 2r by pi. If suppose someone gives you theta is equal to pi by 2, it's a quarter circle. Remember, we derived this assuming the bisector is a reference. So center of mass will be here, whose coordinates will be 2r by pi. Comma 2r by pi. How did we get this? Because this distance will be 2 root 2 r by pi. So all what we measured is the distance from the bisector. There, these are some the common shapes. So if you know the sector, you can find for all this. Semicircle is a standard result. Can we say because it is symmetrical on y-axis, y-center is half the arc is seen as the whole thing? I don't know what you're talking.
So if we just integrated from 0 to theta by 2 and got that, its y coordinate, then would that be the same as the whole thing?
You're saying if you integrate from 0 to theta, then what you did was you
Yes,
found the
sir.
center mass of this piece.
Yes, sir.
But the next coordinate won't be 0, no? Then
Yes, sir, but we can assume it cancel out, like, but at least y should be
why
same.
bol raha hu? Don't assume so many things. Why bol raha hu? You will, yeah, what you're saying is right only, but you still not reach that level where you can do this kind of goof ups. This is what you'll do in the final exam also. You will do bits of that and bits of this. Sometimes it will work, sometimes it will mess up, and then you'll not understand why it messed up. I got your point. You're saying is I'll take and half. So iska center mass, iska center of mass. These two ka center mass will be here. So y coordinate will still work. No, that's what you're saying.
Yes, sir.
All I'm asking is, why are you so lazy just to put one more limit minus theta by 2? Why you want to make your life so, weird, like you want to do 0 to theta by 2, and then you want to think and, make something weird. Meaning you need to ask yourself, when I can put minus theta by 2 in the limit and make my life easy, why do I want to make my life so miserable?
Yes, sir.
Right. So that is the thing. So when things are simple, don't mess it up and don't make your life a mess.
Okay.
Simple. Yeah. Because, Vihan, I'll tell you what, the reason why I keep telling you that thing now, in the final exam, you have 3 hours, 2 years ka portion, right? 2 years ka portion, that 3 hours will decide everything. You will be under a lot of tension, right? You'll be under a lot of pressure. During that time, you need to do things as simple as possible. When you learn, to do things simply, exam it will be a flow. Right now, in under that tension, if you start doing all these kind of small things, right now it might be okay because you're in a very comfortable, relaxed state right now, isn't it? There's no pressure. But in the exam center, it is like someone's pointing a gun at your head and you're trying to solve the paper. Even a small things, I have seen people doing goof ups. I'm telling you, this year, the guy who got 700 rank, 720 IIT Bombay mechanical, 12 minus 6, he wrote 18 and came in the answer. अभी तू बताओ क्या करेंगे उसका. He wrote 12 minus 6 is 18 and came. उसका छोड़, मैं खुद किया था. 3 into 3 6 and came. I did this in the chemistry paper and came. Actual JEE Advanced 2006 का पेपर था ये. You're getting it? So we do really dumb mistakes under pressure. So when you're learning now, always keep that in mind. What you're saying, your method is not wrong, but there is a much simpler and easier way to do. So let's not go there. You're not wrong.
Yes.
So every time I teach you, right, I keep this in mind and teach you guys. So I try to keep it simple. Maybe my steps sometimes are longer, but I'm sure it is you can easily replicate it. Is this clear, everyone? Sure. Next one. But Vihan, don't stop thinking. Keep thinking that way, but then tell yourself again, okay, I could have done it in a more simpler way. I just went roundabout. Nah, that is important. You should say what I did was not wrong, but this is long. At that one point of time, right, after doing like this, I think for another 1.5 year, just before the exam, maybe you will get into a state, you will be in a zone. And that day you'll be better than me. You'll do things much faster than me. That is the whole point of the game, everyone. You guys should become better than me, at least on the day of the exam in physics. And I've seen that, you've seen us do become a last 1 month, may you should see your seniors. People who are prepared, solving now. The way they do questions, right? I feel like, yeah, kya speed hai. Even I did the same thing when I was in my 12th. So we are making a circle with 4 quarter circles with different densities. Lambda, 2 lambda, 3 lambda, 4 lambda. Radiuses are. Find the center mass of this ring. Ring is constructed with 4 quarter circles. Of linear density lambda, 2 lambda, 3 lambda, 4 lambda. Find center of mass. Now you should know your result for this quarter circle. There, that is a result there. 2r by pi and 2r by pi. If you don't know that, then it's a problem. Now can you try? That's it. Once you know that, it's quite easy. You make the 4 arcs into 4 points and find the center of mass. That was the story every time. Try. I'll give you a minute or two. Any answers? Should I show you? So basically, it's like 4 points now. So this would be 1 point whose coordinates will be 2r by pi, comma 2r by pi. Mass will be m. Here also you'll get 2r by pi, but the y coordinate will be minus 2r by pi. But remember, it is 2 lambda, so mass will be 2m. Are you getting? So for any quarter circle, that is the dimension. This will be minus 2r by pi, comma minus 2r by pi. Because it is 3 lambda, mass is 3m. Minus 2r by pi, comma 2r by pi, mass is 4m. Done. So basically for these 4 points, you are telling to find the center of mass. So when you do for x center of mass, it will be m1 x1 plus m2 x2. 1 plus 2, 3, 3 will cancel. 4 by 10. 4 by 10 2r by pi. That is 4 minus 4r by 5 pi or 0.8 r by pi. My center of mass will come out to be 0. Check. So the main idea is to get the coordinates, and the masses will be in the ratio of m2, m3, m4, m, and then you're done. It is simply m1, x1, m2, x2, and this thing. Please check your calculations. I skipped that solving part. Meaning I did it manually, but anyone not convinced with this? Next one. Easy. It looks easy because you know the result. If you don't know the result, then it's a mess. Let's see one more. Let's see how they'll ask a question. The reason why you should know this integration, right? Advanced when they'll frame these kind of questions. We have a semicircular ring. Theta is measured from here. The density is lambda not sine theta. So this density is changing with theta. Find center of mass. That's a non-uniform ring, meaning see, at this point theta is 0, means there is no mass. Here theta is 90, meaning density is maximum. Theta 180, again density is 0. So if you look at this ring, this is how it looks. So it has little mass here, little more, more. Here it is the heaviest. Then again it decreases. You're getting how is the ring? The ring becomes heavier as you go up and becomes again less as you come down. So it's a non-uniform ring. Find the center mass of this. This would be a good advanced level question, a moderate one. Now you know how to take elements for a ring, meaning arc, RD alpha, same story. Try. I'll give 2-3 minutes. These are the kind of questions for what you're learning all that stuff, how to choose elements and all. How do we start? Think it's okay if you don't get an answer. Okay, Vihan God, according to you, this semicircle and that one both are same. They're not different at all. It's like
Uh,
saying Amitabh Bachchan and Amrish Puri both are identical.
Check
Is
my
that what you're trying to say?
calculations.
This beautiful uniform semicircle is like Amitabh Bachchan. This thing is looking like Amrish Puri, villain types. And you're saying both are same.
Check my calculations.
Check calculations, definitely it is wrong. You proved it for uniform mass, God. Try. Take a minute. I'll show you one step again then. Whatever you think you do, it's fine. At least get something wrong. Hmm. Let me show you one. First thing, when you see this question, can you guess something? You can guess. Here the density is 0. It is increasing, maximum. Then again decreasing. Can you see this is a line of symmetry, right? Left and right are identical, isn't it? देख के तो पता चल रहा है ना, left and right are identical. So this much I can guess x coordinate is 0. Is that making sense? X coordinate must be 0. इतना तो पता है. That is the advantage of knowing that symmetry part. All those points that I wrote last time is for something like this. So at least you'll be able to eliminate one or two options. But let's try to calculate anyways. I'll show for the x coordinate, you do for the y coordinate. Same story. At an angle theta, take a small slice d theta. So this piece will be r d theta. So dm will be lambda into length. But what is lambda? Lambda naught r sine theta d theta. So mass is also changing at every point. What are the coordinates? From here, if I drop this would be r cos theta, this would be r sine theta. So coordinates of these points are r cos theta, comma r sine theta. These are the coordinates. So for the x center of mass, the formula is integral x dm by integral dm. So this guy would be x is r cos theta, lambda naught r sine theta, d theta. Here theta is going from 0 to 180 degrees. This would be lambda naught r square, multiply and divide by 2. This will become 2 sine theta cos theta, that is sine 2 theta. That would be r by 4, 1 by 2, cos 2 theta, limit 0 to pi. This is minus r by 8. If I put the value cos 2 pi is 0, cos 2 pi is 1, cos 0 is also 1, cancel, cancel, you'll get 0. Cos 2 pi is cos 0, right? That's cos 0 minus cos 0, 1 minus 1, that is 0. There, as we expected, x coordinate is 0. This is how you integrate. Now, can you do for the y coordinate? I'll give you a minute. The only thing you have to change is, यहाँ पे r cos theta का place में it will be r sin theta. Check. See where you messed up. That x coordinate you could actually see and figure out, like, because the sine function is symmetrical, right? 0 to 90 and 90 to 180 will give you the same values. So sine function is actually symmetrical about 90 degrees on either side. Get the y coordinate. Just give it a try. I'll get some water and come. Let's see. Integration, you'll get a sine square ka integration. And we did that in the calculus. To get the y coordinate. So y coordinate of center of mass, integral y dm by integral dm. This would be r sine theta. Right, we have lambda naught. Nee, Surya, you got a 2 extra. Lambda naught r sine theta d theta. This goes from 0 to 180 by integral lambda naught r sine theta d theta 0 to pi. So this is lambda naught r square. This will be sine square theta d theta 0 to pi by lambda naught r integral sine theta d theta 0 to pi. Now, what is sine square integration? Sine square theta d theta 0 to pi is 1 minus cos 2 theta by 2 d theta 0 to pi. So take out half common, you'll get integral d theta minus half integral cos 2 theta This would be pi, and this would be half sine 2 theta. Cut 2, limits will be 0 to pi. Minus 1 by 4. This will be sine 2 pi minus sine 0. This is 0. This is also 0. So pi by 2. So this would be numerator mein r into pi by 2, and denominator mein you'll get it. You can calculate. That would be pi r by 4. That's your y coordinate. And the sine square, right, is not the first time you read this. If you go back to calculus, there, remember, see the star? Integral sine square. And this is how you did this exactly same process. Have a look at this. You wrote sine square x is 1 minus cos 2x, and then you integrated the whole things. Is this making sense, everyone? So sine square x and cos square x were quite important integrations. That's your answer. Y coordinate is pi r by 4. Have a look at this. Clear, everyone? Make sense? After the class gets over, today or tomorrow maximum, sit and resolve each and every question again. Because these questions are not tough, but they should know the process. You should get used to it. The moment you see this thing, you should know, element aisa lena hai, this is how I should do. Clear with this? All got this? Any doubts on this? Next thing. An arc disk. So that is for an arc. So if you have an arc disk, how do you choose elements? So radiuses are surface density is sigma. So the elements would be like this. You take thin slices. So elements are thin rings. If you ever seen an onion ka slice, you would find pieces like this, meaning the idea was this. How do we do these kind of questions? We will consider this as combination of thin rings. Right? And then I can say for each ring, there will be a center of mass. This is the center of mass of each semicircle. Now these center of masses I will find a center of mass. So center of mass of all these points is center of mass of the semicircle or the arc disk. Is that making sense, everyone? Isn't that what we do normally? If you have a system, we divide this. So how do we do this then? So turn in the page. Any doubts? So this is the aft disk. Let's say you take a slice like this. So let this radius be x and let this thickness be dx. So there you took a thin semicircle. Whose thickness is dx. Now for semicircle, where is the center of mass? 2r by pi, just now we calculated. That means this guy center of mass will be 0, 2x by pi, because the radius of this is x. Is that making sense, everyone? So for this semicircle, the center of mass is 2x by pi. Now, if you make this rod into, if this made into a rod, if it is flattened, then this guy will become like a rod whose thickness will be dx, whose length will be the circumference, which is pi x. So what is the area of this small rod? Area of this small rod is length into breadth, pi x into dx. What is the mass of this small rod? Sigma into area. Sigma is mass per unit area. There, I got dm, I got the center of mass. We have everything. So in this, the y coordinate of center of mass will be integral. Remember, this is the y of that semicircle, dm of the semicircle. So you are finding the center of mass of all this center mass of semicircles by dm. So here the y coordinate is 2x by pi. Dm is sigma pi x dx. This goes from 0 to r, so all the rings will go from there, and sigma pi x dx 0 to r. This would be 2 sigma integral x square dx. This would be sigma pi integral x square dx. Sigma will cancel. 2 by pi. This is r cube by 3. This is r square by 2. 4r by 3 pi. That's your answer, everyone. No, don't do that. When you do that, there's a problem. This is the rod ka center of mass. When you bend this, the center of mass is not this. It is somewhere here. We are just making it a rod for finding mass.
So it's actually a wire, but we are like just finding the mass, we have considered a rod.
हाँ, but dx thickness लेना पड़ेगा ना, नहीं तो एरिया कहाँ से आएगा?
Yes. Like sir, that was the thing was bugging, that we are treating it like a wire for finding COM, but then for finding mass, we're treating it like it has some tangible thickness.
हाँ, it has to have a thickness, right? Or else you won't get that. You won't be able to create an area, na? But the dx is so small, you can neglect it.
Okay, yes. So we're doing approximation with calculating CR.
पूरा तो story वही है ना रे. Whole integration is that only, na रे. Doesn't that what we do in integration? You take a small curve, you neglect that, isn't it? All clear with these elements? Please check out the integration. That's how you handle, when you take an half desk. Any doubts on this? Next one. Now, if I make a more generalized result for here, if you take a sector, what's a sector? Ever seen a pizza ka slice? This is theta. So center of mass will be somewhere here. You can prove it the same way. It will be on the bisector. 4r by 3 theta sine theta by 2. So if you take an half disk, you have to put theta is equal to 180 degrees. This is the center of mass. It will be on the bisector 0, 4r by 3 pi. Standard results, you need to mug up these results. Clear? The next shape we have is hollow hemisphere. This is a pretty important one, right? Comes a lot. Don't worry, in the end, I'll make a table for all these results. So we have a hollow hemisphere like this. Radius r and surface density is sigma. So the elements are taken like this. You have done this in calculus. Elements are like this, rings. I'll give you the result though. Center of mass will be here, 0, r by 2. Result, so you should mug up. Let's see how to take this thing. So from the center, at an angle theta, take a thin slice, d theta. Then we get a piece like this. This is how it looks when you remove it. This was the center. This was your angle theta. This width was r d theta. This was r sine theta. And this height was r cos theta. That means for this ring, this is the centromass of the ring, which is 0, r cos theta. So this is the center of mass of each ring. Again, the same story. Now we need to find the center of mass of all these rings, and then we'll find those center of mass. Now, if I cut this, and if I open this, I will get a band like this. If you cut it open, this is the shape you get. Almost a rectangle, where this width will be 2 pi r sine theta. The circumference will become the length of this rod. This will be r d theta. Now see, this things will look weird, but that's what I'm saying. Whenever the thing is this, whenever you see hollow sphere, this is the logic. So you should know if there is a hollow hemisphere, I should take like this. So these things you need to remember. Whenever you have a hollow hemisphere, this is the idea. This is how you choose an element. So area will be length into breadth. You might feel like, sir, how do we get an idea? Then now you know. 2 pi r square sine theta d theta. This will come in at least 4-5 chapters. There you got the area. So what is the mass? Sigma into dA. There, I know the mass of each ring. I know the center mass of each ring. Therefore, the center of mass is integral y coordinate of each ring, mass of each ring. So that integral formula y dm, that becomes a ring now. By ring. It's just a matter of substitution. So what is y coordinate here? R cos theta. What is dm ring? 2 pi r square sigma sine theta d theta. What are the limits? Look at this. If I take theta as 0, you will be here. Theta 20 is here. Theta 30, 40, 50, 60, 70, 80, 90 is the top, right? Means when theta goes from 0 to 90, the entire sphere is covered. Is that making sense for the limits? So theta is going from 0 to 90 degrees. That is how you get the limits. You should understand, like 0 to 90. When you took a ring, the rings as they go up, the angle is changing. 2 pi r square sigma sine theta d theta 0 to 90. There. Once you have got this, you're done. It's just a matter of substitution. So you end up with pi r cube sigma inside 2 sine theta cos theta will become sine 2 theta 0 to 90 pi 2 pi r square sigma integral sine theta d theta 0 to 90. This guy would be r by 2. This will be r by 2. You can solve it. I will leave it to you. Sine 2 theta will come again half cos 2 theta. That will become 2 again. So that will work out. That's your answer, everyone. Check. So the main headache in this chapter, you know what? The main headache in this is if you understood this part, you got it. That is the main idea. The thing in the red box, that is what I want you to understand. Once you got that, after that, there is nothing in the question. It's pure math. And this is not the first time we did this. In calculus, do you remember finding the area of the shaded part? We have taken elements like this. Exactly same thing they go. There we took dA till here. And even then, that told you the same thing. If you know how to take an element, you know how to do these problems. The integration part is actually the easiest one. Choosing an element is the biggest headache. Have a look at this page. Please ask me if you're confused. dm is this, and center of mass is 0, r cos theta. X coordinate is anyway 0. You will find this thing a little overwhelming, but you should definitely practice this once or twice in the next 1 or 2 days. You will get used to it. This will come again next chapter. Then I will again teach you the same thing. Then you will not feel this overwhelming. This again will come in gravitation. Then you will not feel this much again. After doing 3-4 times, you feel like, ye normal hai. In the moment you see this, you'll know what to do. That is how you should think. Don't see something, tough and get scared on day 1. The same thing, if you do 4 times, 5th time, you'll feel, it's fine, I can manage this. So before feeling that way, you will go under that stress. So yeah. Any doubts on this steps, please ask me. Understood how I took this element, the ring, uska open kiya to that area, it becomes a rectangle. That is the main theme there. Now, Arya, clear with this? Arush, Devika, clear? Puroja, Ahana. Next one. Solid hemisphere. These are all the standard shapes. Solid hemisphere. Previous one is hollow. There is nothing inside, empty. But this was solid. Radius r, density is rho. I'll give you the result. 0, 3r by 8. You should mug up, definitely. Now, how do you use elements here? There are 2 ways you can use elements in this. One way to choose elements is discs, thin discs. Like this, you take slices, you cut this into thin discs, or you can take thin hemispheres. Meaning you will choose like this. Ever seen an onion? When you are opening an onion ka layer kaisa aata hai? Onion upon onion, layer upon layer. If you see an onion ka layers, right, it looks like this. thin hemispherical shells. This looks like layers of onion. Now we will do with layers of onion. How to do with the discs? We have done that in the calculus. There was one pretty nice question we did. You guys remember this? Shell is partially filled with water. Where is this? This guy. Find the volume of the liquid. In this, we have taken discs only. You should refer that in case you want to know. This was page 105. There I taught you how to do with discs. So for now, we will do with thin shells. So we take a at a distance x, take a thin thickness dx. So it has a thin thickness. Now we know for a hollow shell, just now we found the center of mass is 0, x by 2, isn't it? So we are actually using the previous result every time. So this is for radius x. What is the volume of this? The small volume is surface area into thickness. The surface area of a sphere is 2 pi x square, half sphere, no? Dx. So what is the mass? Density into volume. So 2 pi rho x square dx. There, you got the mass. What is the center of mass? 0, x by 2. You got everything. You're done. So the y-coordinate of center of mass is integral y-coordinate of the thin hemisphere. So for each hemisphere, we'll have a center of mass. We are finding center of mass of all those center of masses. So here the y-coordinate is x by 2, 2 pi rho x square dx, 0 to r by 2 pi rho x square. 2 pi rho will cancel. You'll get half integral x cube dx, x square dx. There is an r also here. Right. You're done. So half r power 4 by 4 by r cube by 3, 3r by 8. That's your answer. Whenever you get a hollow hemisphere, this is how you take an element. These are the shapes. Have a look at this. Any doubts on the integration? Huh, Devansh? Exhausted. So much integration. Any doubts on this? Clear, Nikhil? Vignajit, Surya, Sharman, clear? There. Now, if I just put down all the results again. So if you take a uniform rod, so whenever you want to revise, you can just see the results. So if x is equal to 0, x is equal to L, the center mass will be in the middle. Now, if you take shapes like, uniform rectangular plate, right? Or if you take shapes like discs, for all of them, right, it will be at the center. Solid or hollow sphere, not hemisphere, these are full spheres. Hollow or solid cylinder. These all are symmetrical shapes. So for these general shapes, if you see, the center of mass will be at the center. These are some standard shapes. Yeah. And then all the things we derived right now, if you take for an arc, you take for a semicircle, you take for a quarter circle, you can take for a sector, you can take for an half disc, you can take for hollow hemisphere, solid hemisphere. This is a quarter circle. So center of mass will be on the arc here. That will be 0, comma, or this thing. All these things we derived. I'm just putting down all in one page, so it will be easy for you to refer to r sine theta by 2 by theta. This will be the center of mass here. This will be 2r by pi. This will be somewhere here, 2r by pi, comma, 2r by pi. This will be here. This will be 4r by 3 theta sine theta by 2. This will be 4r by 3 pi. This will be r by 2. This will be 3r by 8. Clear? These are all the things which we derived today. Other than this, we have another two shapes. Hollow cone. These things we're not deriving, but you can prove it also if you want. And if you take a solid cone, these are important. Mains is the direct results. In a mains, though, sometimes they'll ask you the results directly. This is a solid cone. So hollow cone, this thing is at h by 3, where h is the total height of the cone. Here, this height is h by 4, 1/4, where h is the total height of the cone. But how do you choose elements here? In case of a cone, if you want to integrate, we take elements like this, rings. Just like hollow sphere ka rings, we have to take this and integrate. In case of a solid cone, we take thin discs. There, you should mug up all these results which I wrote right now. Hollow cone, solid cone. These things we didn't derive, but the results are important. Arc, semicircle, quarter circle, sector, half disc, hollow hemisphere, solid hemisphere. These are fine. These are standard shapes. Have a look at this. These are all your continuous bodies ka general shapes. Clear? So do remember these results. So next class when we catch up, we are going to do problems based on this. We are going to combine these shapes, and then we are going to ask you center of mass of those things. And then we'll also see something called cavity problems. What happens if you make gaps or holes in this kind of shapes? Then how will the center of mass get affected? That is one important models. And then we will see motion of center of mass, acceleration, velocity of center of mass, and we'll keep going. Okay, so that is the last one for the day. So next class when we catch up, we'll be catching up on Tuesday. Don't forget, timings have changed. Some people have still not realized it. So do be on time. But on Tuesdays, right, we will start the class at 5:40. I think there are a few students who are having classes, they're getting delayed. So on Tuesday, we'll start at 5:40 till 8. That day, it will be till 8. Thursday also, we'll have something similar, 5:30 to 8. Clear? From next week onwards, we'll have till 8. I'll give you a break at 7 o'clock. Today, I didn't give you because I'm wrapping up early. So Tuesday, we'll catch up at 5:40. Okay? So, yep. So any doubts, anything, you can stay back and ask. And again, I'm telling you, after the class got over today night before sleeping or tomorrow maximum, take a rough paper, each and every step, try to integrate on your own. Getting it? If you do that once or twice, next time when it comes, you will not find it to be weird.